What will be the result of attempting to compile and run the following class? So basically you've got a nested if statement, and if an else will match with the nearest unmatched if, which is that one there. So basically it's going to be if true, and that is true obviously, and then it's going to go if false, and that's obviously false, it'll do the else on that. So if I look at the answer, okay, it'll go to this guy, true and true. That one there. So in indented format now you can see why it is like that. So your if true, if false, else goes if true, and then everything's inside the if true. If false, and then the else, that else matches with that unmatched if. The nearest one as you go back up. Okay? So the if statement keeps going until it reaches the semicolon when you've got no curly brackets. But the Enthuware people put in the curly brackets just to make it very clear what's happening there. All right. Okay, so we've got this particular code. We have to define a method, and then this is the creating the instance of test class, and we're using a while, much like an if. While tc.tester, do that. Now what you need to realize here is that that has to evaluate to a boolean, just like an if statement. So it needs to be either true or false. So that tester instance method has to come back with a boolean, basically, which will be a valid implementation of tester. Well, public boolean tester return false, yeah, that's okay. Tester false, and then it's wrapped as the wrapper, yeah, that's okay. We've only had to select two, so there are two, but let's just look at what's wrong with the other ones. This one is missing a return type. This one is returning an int, and that's no good inside a while. And the same for a string, no good inside a while, has to be boolean. So there are the answers to that one. Okay, this one, next one's a bit more challenging now. Okay, so what we've got to realize here is what changes should be made to the program that will print 54321. So here's an instance variable k. There's a checkit method, takes in a parameter k, does some return based on the ternary operator. There's the print then, which has been called from main. While checkit, so while that comes back with true, output k, and we want 54321. Now, the key to this is that that is an instance variable, and that k there is shadowing it. So when you're inside the method, remember when you refer to a variable, the compiler is going to check the current scope first of all, see is there a variable there called k, and there is in the argument list. If it wasn't there in that argument list, it would come out here and it would find this one, but it doesn't, and that's the problem. That's why no change is necessary, will not work, because k is set to 5, while checkit passing in 5, in we go here. Now that is an unusual looking syntax. What it is k minus minus greater than 0. Okay? So what you're checking here is, well, the current value of that is passed in is 5. If that's greater than 0, return true, which it is, and then reduce the local variable k to 4. Comes back to here, that's true, output 5, back in with 5 again. K never gets changed from 5 with the code as it currently is. So we want to get it so that it'll print 54321. We'll talk about each of them in turn. The next one is the one that will work. This one here. Replace the system.out.print k with system.out.print k minus minus. So this bit here. Output the current instance variable. See, there's no k in print then, so it has to check the outer scope, so it finds the instance variable. So that comes back with true, passes in 5, and is 5 greater than 0? Yes. Output 5 because it's k minus minus, so it'll output the k first, and afterwards it'll decrement it by 1, so it goes to 4. Check it 4, comes back with true, output 4, decrement to 3. Pass in 3, output 3, decrement to 2. So we'll get down to the last one. When you pass in 1 and output 1, because it'll come back with true, output 1, decrement to 0, pass in 0, and that'll come back with false then, because it's no longer greater than 0, while loop fails. This particular guy, the minus minus is before it. So basically what you're doing is you're printing out the decremented value of k first, which will be 4. That will start with 4. And that's immediately incorrect because we start with 5. And it'll go all the way down and it'll output 0 as well. The next one, replace checkit k with checkit k and a minus minus before the k. Again, you're going to end up with 4. You're decrementing the instance variable, k, before you call checkit. Okay, so it passes in 4, comes back with true, and you output 4. Now it isn't output 0 in this instance because when you pass in minus minus of 1, it's going to be 0, and that'll come back with false. So replace the last one, k, true, with that one. The problem here is the k minus minus here. That is in fact the same as that one there. System.out.print minus minus k, and this guy where you're returning this dot k minus minus. So check the this dot k, which is the instance variable, which is good. We're not looking at the local one, and then decrement it. However, when you decrement it to 4, so let's say the first time it's 5, you check 5 against 0, it's going to return true. Then you decrement your k to 4, and then you're going to output 4. So you've got a problem. Got a problem straight away. See if that's right. And it is. So it's a little tricky, that one, but it's all about the scope. The scope of your local variable hides the one of the instance variable if they use the same name. Okay, this particular one, what will the following class print? So the instance variables and the class variables are initialized to various values. The binary 0, which for booleans is false. So they're going to be all false. And then here, what you've got is this expression here. Now we know from the last day that expressions go from left to right. Okay, they're evaluated from left to right. And it's only after the expressions are evaluated that you start to group them. This would take precedence over the or. The and would have higher precedence than the or. But what happens here is that A is assigned true. And this is the short circuit. So because of that, the right-hand side does not even get evaluated. So I just put that in. Let me go into NetBeans because it can be tricky. So here's your A, B, and C. The precedence of and over or determines how we group. Okay? How we group the middle expression, which is B is assigned true, which is shared by the left-hand side, A is assigned true, and the right-hand side, C is assigned true. Therefore, the expression is A is assigned true or, and then essentially there's brackets to group these two together. However, we still evaluate left to right. And that's the proof of that. That is going to get done first. And then because that's true, the rest of it just doesn't get evaluated. Okay? It would only get evaluated if it was false in that instance. All right, so this particular one, which of the following will not give any error at compile time and runtime? Well, that one's okay. 8 is equivalent to 81. That's going to come back with true or false, which is what you need inside an if statement. X is assigned 3, that is incorrect. that comes back with the value 3. That's not a boolean. If true, yeah, that's a boolean. If bool is assigned false, so that is false, if false in other words. And if x is equivalent to 10, you return true, otherwise you return false. That's okay as well. It's a ternary inside an if expression evaluation. There's no problem with that. Double check that now. Yep. Okay, this is better done, this one in NetBeans. So here I have A is set to 10 and B is set to 20 as in the question. You evaluate left to right. The round brackets are for compilation and not for changing precedence. So you don't want to mix up your round brackets here for compilation purposes and for precedence. For example, there. You get away with it in the first one, but not the second one. I need round brackets for that assignment there. But this A plus equals, and in brackets, A is assigned 4. That is the same as, you assume that is the right-hand side. And it's basically A is assigned A plus the right-hand side. Okay, so that's A is assigned A plus A is assigned 4. Which, what's the value? Go left to right again. What's your value? 10. So it's 10 plus 4 because you're changing the A to 4 there. So it becomes 14. And B is the exact same. It's just a fleshed out one, if you like. B is assigned B plus B is assigned 5. You plug in your value of B first of all. You're going left to right. So that's 20. Then B gets changed to 5. So you need to know that you're going left to right here. Otherwise, you'll end up changing B to 5 and then adding it to B, which is 5, and you'll end up with 10. That'd be the wrong answer. B is 20 initially, then it's changed to 5, and then it's changed to 25 because you had to add them together. Now let's reset them and let's do a little bit more about this precedence and associativity. Precedence determines the grouping, i.e. does A go with 3 or 2? So you've got a common term here, and does it go with the 3 or does it go with the 2? Now these sub-expressions have been evaluated at this point. That's important to realize because I've just got constants in here, 2 and 3. There's no round brackets with complex sub-expressions that need to be evaluated. In that case, you would go left to right. But at this point, they have been evaluated and we need to figure out, well, does that common one go with the right-hand side or the left? And that goes to the right because multiplication has higher precedence than a plus. So you end up with 10 by 3, giving you 30, and then you add on the 2, giving you 32. Reset the A again. You can use brackets to change the order of precedence. So the order of evaluation has now been changed from the default one. So it's 2 plus A, then multiply that by 3. So it's 2 plus 10 now, and you multiply it by 3, giving you 36. And then this is just a refresher from the last day. Note that the expression is evaluated left to right, even though it's sub-expression A plus sub-expression B multiplied by sub-expression C. Whereas here, it will be this bit will get done first. Now that you're dealing with sub-expressions like that one there, and that one there, and that one there, they're sub-expressions and they are evaluated left to right. And when they're evaluated, how they are grouped together determines or is based on the order of precedence. So we have to evaluate A, then B, and finally C. Once the sub-expressions are evaluated, then the multiplication is done before the addition. So if you look at the expression here now, the first thing that's going to happen going left to right is x is assigned 2. So x is changed to 2. And then we evaluate the next sub-expression. Now it's a post increment, so whatever is currently in x is what's used in the multiplication. So that's 2. Then x is changed to 3, post increment. We use that x in the next sub-expression. So x is 3 now. 3 by 5 is 15. So you end up with 2 multiplied by 15. So 2 by 15 is 30, and then you add on 2, giving you 32. Now, the overall answer in the initial part of the question was that A was 14 and B was 25. And if I go back to Enthuware, then that is that answer there. And I'll evaluate it. And there we go. The next question is 2.1081. Which of the following code snippets will exactly give us 10, will print 10? I'll come back to the first one in a minute. This one here is not going to do that. Okay, because that's a double, which means you can't have two different types. So that gets converted somewhere in memory to 100.0. Now you've got a double divided by a double, and you end up with a decimal point. And that's a problem. The third one, same thing. Even though it's 10.0, you are asked for exactly 10 up there. Okay. The fourth one, 100 divided by 10. Yes, that's right. The last one, multiplication and division get done first, and in the order they associate left to right. So that's 10. Then you multiply it by 2, giving you 20. Add 3. Okay, 23 minus 13 is 10. That's right. Now the first one here is actually correct as well. And the reason it is that you've got an object reference referring to an integer object with 106 in it. Now we need to make sure that that cast gets done before the int value, because the dot has higher precedence than the cast. But by putting the brackets around the t and the I there, you ensure that that t object gets cast to integer. So now the dot refers to the integer methods, which int value is one of them, as opposed to the object method. Int value is not an object method. Okay, once that's done, you're okay. Integer division truncates. 106 divided by 10 is 10, and the remainder is just discarded. Okay, so consider O1 and O2 denote two object references to two different objects of the same class. Which of the following is true? So really, all we've got is, let's take an example. O1 is referring to person, and O2 is referring to a separate object. Now, what we have is O1 dot equals O2 will always be false. Okay, now you're not given a lot of information here. We don't know if these classes have overridden the equals method. They might have. If they have not, that would be correct, but we don't know. So we can't select it. Okay, it depends. The answer they give here is it depends on how the equals method is overridden. Like for example, string has overridden the equals method to return true if both objects contain the same characters. I might have overridden the person class. String buffer doesn't override the equals method. So it doesn't, not enough information there. The hash code will always be false. Now hash code can be overridden as well. And so the given statement is not true. I'll talk about hash code in a second. O1 is equivalent to O2 will always be false, correct. That equivalent compares the object references. I go back to here. You can see I'm obviously referring to two different objects. Nothing can be said about O1 that equals regarding what it can return based on the given information, correct? We can't say, we don't know. Nothing can be said O1 is equivalent to O2. Well, we do, we know that it's going to return false. Now, just in passing, because they've mentioned hash code here, I said I'll talk about it briefly. It's not on the OCA exam, but it's no harm to have a little bit about it. Basically, if you're overriding the equals, you should override the hash code method as well. So that if you're going to use your object in hash collections, like hash set, then you definitely need it. Now, what does the hash code contract state? Well, it states that equal objects, in other words, where your equals method returns true, they should have equal hash codes. So hashing is a way of trying to make your searching efficient. When you start using collections, you know, and especially hashing algorithms, you know, if you've got 100 objects in your program, the ideal way to store them would be maybe 10 buckets with 10 objects in each of them. At least distribute them evenly rather than have one bucket and everything goes in there. That's not very efficient. Or having 100 buckets with one object in each of them. Again, not very efficient. So if you had a person object, okay, let's go back to this guy. And we had Amy and Amy. Well, those hash codes should be the same because those objects are equal according to the equals. Assuming our equals method here says, well, if the name is the same, then we'll assume they're the same person. Okay. Now, so that they should have the same hash code. Unequal objects can have the same hash code as well, and that's for the efficiency side of things. I could have another person. Let's say my algorithm was based on the letter A. My hash code would get the number 1. Y would get the number 25 because this is the 25th letter of the alphabet. Obviously, they're going to come back with the same hash code number. But I could have an O3, another person, and the name might be May. Same letters. So they should end up, they're not the same object, obviously, according to the equals method, but they should end up in the same bucket. They will end up in the same bucket according to that algorithm. Because 1 for A, 25 for Y, and 13 for M, you add them together, and May and Amy will end up in the same bucket. So that's why I always think of the unequal objects will end up in the same bucket. There's no rule on that front, but the rule is if your objects are equal, then they should have the same hash code coming back. Okay. Now, even if it's the same hash code for every single object, you might override the equals method, comparing the name. You might override the hash code and return 7. That's it. So everything goes into the one bucket. Not very efficient, but technically it's correct. There's nothing essentially wrong with it, but except it's very inefficient. Okay, that's just an aside on the hash code for fear it might ever come up. Okay. This particular piece of code, what if anything's wrong with this code? Well, there's an int switching on the int. Are they all fitting into int? Yes, they are. Default can be anywhere. No breaks, you don't need them. They're all compile time constants. Nothing wrong with the code. I just want to read out some of the stuff that's here. Only string and then the integral types, byte, char, short, and int. They're the numbers, if you like, whole numbers, and the wrappers of them, byte, character, short, and integer, and enums can be used as types in a switch variable. The case constants must be assignable to the switch variable. For example, if your switch variable is of a class string, your case labels must use strings as well. The switch variable must be big enough to hold all the constants. For example, if the switch variable is of type char, then none of the case constants can be greater than 65535 because a char's range is from 0 to 65535. All the case labels should be compile time constants. For example, final int I is assigned 3. And wrappers are not allowed as they are evaluated at runtime. No two of the case constant expressions associated may have the same value. So I couldn't have another case 4 here because there's one there already. And you can only have one default statement as well. Now this one is better done in NetBeans. Oh, I had done this in NetBeans as well. Just to show you, this is the previous question. Here's a switch statement. And here's some compile time constants, X and Y. Final, primitive, and their assigned values when you declare them. I is not a compile time constant because it's wrapped at runtime. Integer I is assigned new integer, 15 is what happens there. It's not resolved at compile time. It needs to be. So 1 that's a constant, no problem. X and Y are allowed, no error there. 2 by 2 is allowed because that resolves to 4, which is just a constant. Z and I are not allowed. The I we saw there, even though it's a final, that's a wrapper, not allowed. And Z is not acceptable either, just because it's static doesn't mean anything. Doesn't mean anything. And this is why doubles and floats aren't allowed in a switch statement. I'm adding 0.8 and 0.4 here. And when I output it, I get this number with a 2 at the very end of it. Peculiar. So we can't obviously have that. So this was number 10. Okay, so here's your x1 is assigned -4. So that gives you x1 is assigned -4. Here's your x2 is assigned x1 minus. So what happens there? x1, as it currently is assigned into x2, and then x1 is decremented because the minus is post decrement. So the first bit is A here. x2 is assigned whatever's in x1 at the moment. So that's -4 goes in there. And then we decrement -1 by 1. So x1 goes from -4 to -5. Then we say, okay, let's declare an integer x3 and make it plus x2. So the increment is now pre-incremented. So x2 goes up by 1 and then the value goes into x3. So x2, which was -4, is incremented by 1 to -3, and that value -3 goes into x3. So now you have x1 is -4, x3 is -2, and x2 is -3, and x3 is -3. We do an if statement. If -3 is greater than -0, that's false. So we then go along and we say x1 plus. Now, there's no difference as whether the plus is before or afterwards there. It's just a statement all on its own. So it doesn't matter if it's pre-incremented, post-incremented. Here, yes, it does. Because there's an assignment or a system without that print line, it'd be the same idea. So x1 plus means x1, which was up here, goes from -5 to -4. The result then of adding the 3 together is -10. Let's go back here to Enthuware and load up 2.986. Okay. The following method will compile and run without any problems, true or false. Okay, so we have a switch on a byte. Case single quotes around a B. That evaluates to the ASCII value or the integer value of lowercase b. And what is a very handy thing to remember is that all of the letters, uppercase or lowercase in the English alphabet, and the numbers are below 127. So they're all assignable into a byte. So number 1 there is okay. The default, that can appear anywhere. Case -2, byte is -128 to +127. 0 is considered positive. So if 256 overall, 128 negative, 128 positive numbers. And then case 80, yeah, that's well within the range. -128 to +127. So it's okay. Okay, and then it gives you all the bits and pieces. We talked about that on a previous one. Okay, which of the following expressions will evaluate to true if preceded by the following code? And this will be easier to see in memory. So the first thing we're doing here is that to remember that that is a string literal. It's in double quotes. So that goes into the string constant pool. And it's an object because it's a string. String constant pool. Then we've got a character array. Now, an array is an object. So that is also an object. So that's going to go onto the heap. So we'll have something like that. String C is assigned new string with B inside it, okay, which is a valid constructor call. Note that we use new. That means you create a new object, regardless if it was a string literal you were passing in or not. That is a new object that goes onto the heap. Yeah, that should be Java here. Now, string D is assigned A. Okay, now we have to select three options here. Which of the following expressions will evaluate to true? A equivalent to D. Yes, that's easy enough to realize. A is equivalent to D. They're both referring to the same object, so that's correct. B equivalent to D. Well, one is an array and the other is a string, so that's not a valid comparison at all. Okay, they're different types. A equivalent to Java. Now that's a string literal. String literal goes into the string constant pool and it'll find it in there. So A equivalent, yes, it'll reuse it. So when it's using this guy, it'll reuse that guy. So A equivalent to that is correct. And A dot equals C is correct as well, because the string equals compares the letters inside of the string. Okay, note that A is equivalent to C will be false because we did a new. Okay, A equivalent to C will be wrong, the double equals, like that one there. A equivalent to C would be wrong because we're looking at two different objects, but A dot equals go in and compare the letters, and the letters are Java, so that's okay. Okay, this particular one is the crucial part of this one. What changes can be done so they will only print true? Now, first of all, it says, well, no changes are necessary. Oh yeah, changes are necessary, all right, because you're saying switch on get bool, which is returning a boolean. It's true. You cannot switch on a boolean. Okay, enums, yes. Strings, yes. And then your numbers, your whole numbers. You know, your byte, your char, your int, your short. Those ones. Just think of those ones. And a string. Cannot switch in a boolean, a float, or a double, or a long. The big numbers. Those ones. Just think of the integral types, the integer types of the small, you know, an int and smaller. So that's wrong. And case true is wrong as a result. So what we can do here is we can, instead of calling get bool, there is a get string here which returns a string. We can do a switch on a string, no problem. So instead of get bool, we'll call get string. That'll return a string and it's going to return true as a string. So if we put double quotes around that, it becomes the string case true, which will output true. What changes can be done so they will only print true? That's it. Change that method call to call that method and change that to be a string. In other words, put double quotes on either side of it. And that's what's going to come back from the method anyway. So call getString instead of getBool, and also change the case label from true to true. Okay. Okay, assuming that a valid integer will be passed in the command line as the first argument, which statements regarding the following code are correct? So you have the parseInt of arg0, so that takes in a string, converts it to an int. Switch x less than 5 is true or false. That's a problem again. Switch x, okay, you're switching on an int, that's fine, but you can't be having a case on a boolean. For the same reason you can't switch on a boolean, you can't have a case on a boolean. It's not allowed. That program is not going to compile. And that's what is the answer to that one. Okay, which of the following implementations of a max method will correctly return the largest value? Now, it's handy here is when you have to only select one and you're told you've only got one that's correct. If you spot the one that's correct, which is this one, makes it very easy. Here's your max, it returns an int, takes in 2 ints. If x is greater than y, you return x. That's grand, it's the greater number there, the largest number. And then other than that, it'll return y. So in other words, if that fails, it returns y. Well, let's look at the other ones. Here, you've got a return, and then you've got an if statement embedded in it. And then there's no return on that x there at all. So it's just syntactically incorrect. Here you have a return. If you took out the return and that round bracket, and you took out the round bracket back here, would be okay. If x is greater than y, do that block which returns x, else do that block which returns y. And here, switch x less than y, that's a boolean. Case true, that's a boolean, that's a problem straight away. Okay, this particular question is predicated around the plus equals. So here you have a method, mx, which takes in an int s, and then you're looping, adding 0, 1, and 2, which is 3, onto that s, and you're returning s. So you're adding 3 to whatever comes in here, and you're returning that value in there. Declaring s to be 5, s plus equals, s is assigned mx with s plus s. There's a lot of s's going on in here. So when you say s plus equals, that's the right-hand side. So it's s is assigned s plus that. So I'll look at that, and if I show you the document camera, you've got s plus equals, and that's in purple, some expression. That'll be converted into s is assigned s plus some expression. So that's, I've written it out here. S plus equals, this is the right-hand side, the expression that's up here. Put that on the right-hand side. So that's the same as s is assigned s plus the right-hand side in yellow, which is the same as s is assigned s plus, and then I plug in the right-hand side. I plug in the right-hand side. So that's 5, we're going left to right, 5 plus mx5, it adds on 3, returns 8, plus the addition of 1 onto s is 6, going left to right. So then you add them, and the precedence of the operators, this is where they would come in if you needed them. But you don't in this case, it just associates left to right, and you get 24. Okay, what is the result of executing the following? B1 is assigned false, B2 is assigned false. If B2 is assigned B1 equivalent to false, output true and output false. And the answer is true. Let's look at that. The assignment is the least priority of them all. So equivalent has a higher priority here because all these expressions are already evaluated, if you like. You're dealing with simple expressions now. So B1 is equivalent to false is the first thing that's done because the equivalent is higher precedence than the assignment. So B1 equivalent to false, false is equivalent to false, that's true. B2 is assigned true. So it's a boolean has been assigned true. So therefore that's true. And therefore the if statement is true and it outputs true. Okay. Fairly straightforward one. Okay, so this particular one, we're creating an object and then we're object 2 is assigned object 1. So they're both looking at the same object in memory. If object 1 dot equals object 2, then, well, it's true. But it's interesting to know why. The object equals is the same as the double equals. In other words, are the references pointing at the same object? So if I just evaluated object classes equals method just checks whether the two references are pointing to the same location or not. So that's what we're calling there. Are they both referring to the same object? In this case, they really are pointed to the same location because of the object 2 is assigned object 1 statement. So it returns true. Okay, number 19 is, I'll show it to you in NetBeans, but we'll just look at it first here. 2.929, we've got some booleans set to true and set to false. And then we're going to come along and we've got so complicated looking if statement. So you can go ahead only if the following expression evaluates to true. What variables can you put in place of the question mark? There. That's what we've got to figure out. So let me go to NetBeans to have a look at that. Now, this is the code here. The green light, the pedestrian, the right turn. Now, that big, long, complicated looking if statement is basically if A or B is equivalent to true. That's what you're trying to ascertain. When you break it down, that's what it is. Now, A is quite complicated as to what it is, but that's what it says. If A or B is equivalent to true, the overall if statement is then true, naturally enough. The equivalent to true doesn't really matter, okay, but it's in there anyway. This is what A is equivalent to: right turn and not pedestrian or other lane. Right turn is true. And not pedestrian, well, pedestrian is false. Not false is true. You now have true and true, which is true. And then you have an or. So that's going to short circuit. Okay? It's going to short circuit. So basically, the answer is any variable will do because it's going to short circuit. Before there, on the left-hand side, we have just worked it out that it will be true. So it'll short circuit. So I just put in a sample here. I declared I to be 0. And I have a plus plus I here, pre-incremented, and then output I. Does I get incremented? If it comes into this part of the statement, it will get incremented to 1. But it never does. It comes up with true and 0 there. See that? So it's complicated, but that's basically what happens. It's just this bit here ends up being true. So you end up short circuiting there with that guy. And then this whole thing here short circuits because that's a true overall and that's an OR as well. So any variable will do, it doesn't matter because of the short circuit. And a nice simple one to end with. Multiplication, 4 by 3 is 12, plus 3 is 15, 2 by 3 is 6, plus 4 is 10. Add the two of them together, get 25.